In this exercise, we're going to discuss dimensional display and their relationships. When you apply dimensions to your sketch elements, additional options are available that you can use to control the display of dimensions. Also available are tools designed to assist you in creating dimensions referenced from other features and/or dimensions. After you apply dimensions to your geometry, you can control the visibility of all dimensions in the sketch and control the visual formatting of the displayed dimensions. What this means is we get some visual cues from our dimensions inside of a sketch. For example, this dimension here with the fx 0.866 tells me that this is a function or a formula based on something else. If I double click on it, it tells me that dimension 6 equals to dimension 5, which happens to be 0.866. This is an imperial measurement, but if I actually look at dimension 5, it's 22 millimeters. So it's actually converting it from metric to imperial and then using the same value for this dimension. If I want to control the way these are displayed, I can just right click anywhere in empty space and go to dimension display. I can show the value, which is basically what we're seeing now. I can see the tolerance, which is the default. It's what you see out of the box usually. I can see the name, and it tells me what the dimension name is. This isn't very useful because it doesn't tell me the dimension at the same time. I can see the precise value. This is really nice whenever I'm trying to make sure that my dimensions are actually typed in and not calculated, or if you apply a dimension and it looked close and you just accepted it. For example, this 22 millimeters, this just shows me what it's rounded out to whenever they do the conversion and convert it from metric to imperial. If I wanted to clean this up, I could convert this from 0.86614173323 to just 0.866 or something like that. And then lastly, but not least by any means, I can go to expression. This is probably one of my favorite dimension displays that I use the most often. What's really good about this is it tells me the name of the dimension and what the value is. So it's telling me that this is D5 and I typed in 22 millimeters. Because Inventor understands the difference between metric and imperial, if you are in an imperial template and you type in 22 mm, as I did here, it understands that I mean 22 millimeters. Likewise, if you are in a metric template and you type in 0.125 IN, it understands that you want to convert that over to an imperial measurement. The expression gives you formulas, so D6 equals D5. If I had a dimension in here, say I had 0.25 minus 0.125, it would give me that full formula telling me what it is. And then I can actually see the names of them so that if I need to use them in another formula or figure, I can actually just type that in now. And for the most part, what I do is I leave it at the tolerance. And then whenever I need to, I can toggle back over to that expression. It's one of those things kind of like Ortho and AutoCAD. You can toggle back and forth in it. I do that quite often. I'll right click and go into that dimension display and toggle back and forth. Now, we have all of this information in Inventor. And unbeknownst to the user, we've not actually been drawing an Inventor. Even though it looks like you're putting lines, arcs, and circles into a sketch, and then you're modeling those into 3D objects with extrudes, revolves, fillets, chamfers, we're not actually drawing. We're actually just adding to this huge database that controls everything. Inventor automatically creates parameters for everything inside of the model. So all of these dimensions, these D0, D1, D2, D3, are automatically added to the parameters table. If I come up here to the top and I click on the FX, it shows me my list of parameters. These are automatically created by Inventor, and they show me what my information is inside of my model. It shows me what was actually entered in and what that nominal value equals to. Now, one of the things I like to do is objects that I need to modify or need to remember, for example, the width of this rectangle, I will come in here and name it. You'll notice it automatically renamed D5 to width in both locations. And if I change this to height, say done, and then I come over here and change my display to expression, you see now that the height of this rectangle equals the width, therefore making it a square. This allows me to reuse information easily without having to remember what dimension equals D7 or D8, and use simple nomenclature that will easily be used later on. The other option we have with parameters, if I come back in here and make this D6 again, and I come up here and make this D5 again, what I can do is I could make a new parameter called height, a new parameter called width. And I could say height equals width, and width equals 22 millimeters. And then what I could say is D5 equals width, and D6 equals height.
I can change these parameters to anything they need to be. By renaming the parameters, it gives us greater control and be able to reuse them inside of the design. With the named parameters inside of a part, we can have multiple sketches referencing that exact same measurement. You can create these by creating a new user parameter. Down at the bottom, you can say add numeric or add text. Or you can rename one of the existing parameters, such as D0, D2, D5, that Inventor creates as you go and create dimensions in your sketches. Either way, you can actually start using these under the list parameters option inside of dimensions. By renaming these parameters, I'm capturing design intent. I'm passing that knowledge to either myself or the next person that will remember that this is what this dimension is for. It's very important to capture the design intent in Inventor as early as possible, and this is one of the ways that we capture that design intent. This design intent helps capture the relationship between dimensions. Inventor then remembers that there is a relationship, and so if one number changes, it automatically changes both. In this example, you'll notice that height actually equals width down here at the bottom. So now if width ever changes, height will change as well. This could be a formula. Height could be width times 1.25 or something like that. Inventor will remember that and change it in every sketch that references height or width. So it passes that design intent from sketch to sketch to sketch without you having to remember what you typed every time.